So today I will be talking about calibration. Now what exactly is calibration? To define it in a very simple terms, calibration is a process where we compare input value with standards. So if you were to look at a graph for calibration, on x-axis we have input, on y-axis we have output, and we have a standard line on the ideal curve. And this follows a principle of linearity. So anything you measure, the input goes on x-axis, output on y-axis, and your readings will fall on this ideal curve or the standard graph. But that is never true in real life. In real life, the curve looks like that, the measure curve in blue. So if you look at this curve, there is a huge errors at the lower values, whereas it's very linear at the upper part. So this instrument will be fine to be used at higher values. The higher values can be trusted, but not the values at the lower end where there can be huge errors. So when we talk about calibration, we talk about accuracy and precision. So what is accuracy and what is precision? Now accuracy is basically refers to freedom from error. How closely the measured values are to the standard values. Okay, how they conform to each other. That is accuracy. Whereas precision is about exactness of successive measurements. Okay, so this is about refinement of the measurements. Okay, every time you actually do a measurement, it is almost the same. It's not different. That is what is precision. So if you look at accuracy and precision as a bell graph, so x0 is true values and xi is the measured values. The difference between them should be as small as possible. Okay, so that should be as close to each other as possible for any equipment or machine to be accurate and precise. So if you look at precision, it's like a target practice. Every time your aim is to hit the bull's eye. Now let's look at this graph. We've taken a machine and we've taken the measured values at lower end and at the top end. We've taken a whole range of measurements. And these values fall on these graph like that, way I've shown here. So is this machine accurate or is it precise? It's very difficult to say. But if you look at a target practice, this is how you will see the values. You will see that none of them hit the bullseye, but they are very close to the standard of the x0. So delta x is small, pretty small. So this is accurate but not precise because every time you take a measurement you get a different value. It's very near to your standard value, but it is away. Okay, there is always a difference. Okay, so this is accurate but not precise. Now look at this graph here. All the values are falling in a line. Okay, and if you see it, they are far away from the target. But every time you make a measurement, it's absolutely the same measurement. The degree of error remains the same. So this is actually precise but not accurate. And this is what we like for most machines, that all the values should fall on the ideal curve. Okay, and you need to hit the bullseye every time for any machine to be accurate and precise. So when we talk about calibration, we talk of one-point calibration and two-point calibration. Now one-point calibration, most machines will do it. Now this is different from zeroing. Zeroing is part of one-point calibration. So let's see a machine which has been calibrated and having one-point calibration, and the point you get is the yellow one seen on the screen. So what can you infer from this? Is this machine accurate? Is it precise? No, we can't tell, can we? Now let's assume that the 0 is 0 and the line actually passes from 0 to the measured value. And if you look at the graph, there is a slope. This is called a slope drift. The machine has got a slope drift. So if you look at the differences, they're huge at high value, but very small low value. But you could also assume that the line passing through the measured value is parallel to the ideal curve. In this case, there is something called an offset. So with one-point calibration, we cannot say whether there is a slope drift or there's an offset. Now to know whether there's an offset or a slope drift, we do something called a two-point calibration. Okay, so you take a value at the lower end and value at the higher end. Okay, and say for this equipment, the values actually have a slope drift. There's a huge slope drift. What it basically means is that the values at higher end cannot be trusted. There is a huge difference from the ideal curve, but at the lower end, they are fine. Okay, and when you do a two-point calibration, you get 2 points like this, and we can say that there's an offset. That means there is a constant difference between the lower end and the higher end of the values, and all you need to do is to reset. So there can be a difference of say 1 millimeter of mercury at the lower end, and the same difference remains at the higher end. These machines are alright to be used as long as the offset is very small. If the offset is huge, then you need to actually recalibrate it. Also, you need to, for the machine which have a slope drift, that surely needs recalibration. But with the offset, you can use them with the smaller offsets. Now, calibrating transducer. How do you calibrate transducers? Okay, some of them actually come with electronic calibration. You press a button and it calibrates, like in this case, to 100 milliliters of mercury. Now, this would be a one-point calibration. You can always do the zeroing as you normally do for any transducer. The transducer basically is a Wheatstone part of a Wheatstone bridge, and the present transducers, they are calibrated in the factory, and so we don't have to calibrate them. But some of the older transducers you could actually calibrate in the theater itself. Now this is what the setup is. You put an arterial line in, you got the setup with the pressure bag, you got the transducer connected to the monitor, and all you need to do is connect the tubing to the arterial line. And you get after you have zeroed and you had actually set it up, then you get the reading on the machine. You get a trace. Now, how do you know that the blood pressure measured by this is accurate or not? So this is where the two-point calibration comes in. And this is in addition to the zeroing you do. So first thing you have to do is you have to zero it. So you switch off the arterial line, you disconnect it from your arterial line, okay, and you connect it to a sphygmomanometer. And then you start pumping it to 50 milliliters of mercury, and the graph should show 50 milliliters of mercury. That is if it is accurate. Then you pump it up to 300, and the graph on the screen should show 300 milliliters of mercury. Okay. So if we look at it graphically, okay, this is the points you get. So the 2 points, the 0 is 0, at 50 it shows 50, at 300 it shows 300. Okay. So this is a well-calibrated machine, but you could actually get points which could be at lower end, so they have a lower drift, slope drift, or a higher slope drift. Okay. So the green one actually will give you values which is lower than normal. So If your blood pressure, the patient's blood pressure is exactly 180, actually, it will likely show you as a blood pressure of say 90 or 100. Whereas in the blue one, when your blood pressure is 90, it will show 120. So these are not these machines need then, or the transducer need to be recalibrated. Thank you very much. Hope you have now got clear understanding of calibration. You know what accuracy and precision means, what is zeroing, what is 1 point calibration, and what is 2 point calibration, and how you calibrate the transducers. You can find me on www.anaesthesiaworld.com or on my Facebook group, The Anaesthetist.